Introduction of torque. Torque is a fundamental concept in physics and engineering that describes the rotational force applied to an object. Learning how forces cause rotational motion is important for the design and research of mechanical systems such as engines, gears, and levers. The things of a force and the distance measured perpendicularly between the axis of rotation and the force's line of action is known as torque in mathematics. This vector quantity, which is generally measured in Newton meters and m, is defined by both magnitude and direction. The history of torque. The concept of torque has its roots in ancient mechanics and physics, where early thinkers studied levers and rotational systems. The first one is ancient foundations. The principle of torque can be traced back to Archimedes of Syracuse, circa 287 to 212 BCE, who formulated the law of the lever. His work laid the groundwork for understanding the relationship between force and rotational motion. Archimedes' insights on the balance of forces on a lever were among the earliest contributions to the study of torque. The second one is medieval and Renaissance developments. During the Middle Age and Renaissance, scholars like Galileo Galilei expanded on these principles, exploring the dynamics of rotating systems. Galileo's experiments in the 16th century provided a more comprehensive understanding of motion and force, indirectly contributing to the modern concept of torque. The last one is modern physics. The formalization of torque as a distinct physical concept came with the development of classical mechanics in the 17th and 18th centuries. Sir Isaac Newton's work on rotational dynamics and angular momentum laid the theoretical foundation for the study of torque. Next is the background of torque. Torque has become a cornerstone in engineering and technology due to its wide range of applications. First one is automotive engineering. When designing engines and transmission systems, torque is essential. It assesses a car's capacity to carry out operations like towing and acceleration. Second one is structural mechanics. Engineers can make sure that buildings like towers and bridges are stable when subjected to bending or rotating forces by using torque evaluation. The third one is industrial machinery. Torque is necessary in the operations of machines like turbines, gearboxes, and robotic arms, where rotational movement is key to functionality. And the last one is everyday tools. From wrenches to screwdrivers, many hand tools depend on the principle of torque to function efficiently.
Okay, definition of torque. Torque, often referred to as the moment of force, is a measure of rotational force that causes an object to rotate around an axis or pivot point. Mathematically, it is expressed as torque equals to force times distance, where force is the magnitude of the force applied, r the perpendicular distance from the axis of rotation to the line of action of the force, also called the lever arm. Torque is a vector quantity, meaning it has both magnitude and direction, and is measured in units such as Newton meter. Okay, why torque is important is because torque is critical in understanding and designing systems involving rotational motion. Its importance can be summarized as follows. Rotational motion. The way force drives objects to rotate is explained by torque. Angular acceleration, which is required to the functioning of wheels, gears, and several other systems, would not be possible without torque. Mechanical advantage. Torque is key principle in levers and other simple machines. By increasing the distance, lever arm, a smaller force can create a larger rotational effect, making tasks easier to perform. Next is automotive and machinery design. Torque controls an engine's power production and its capacity to accelerate or move loads in automobiles. It controls the effectiveness and operation of parts like gears and pulleys in machinery. Okay, structural stability. Because of torque inspection, buildings, bridge and other structures are hard to get damaged and rotating force caused by around pressures like wind or earthquakes. Next is everyday application. Torque is the concept behind the use of tools like wrench and screwdrivers, allowing nuts and screws to be tightened and loosened efficiently. Lastly is dynamic control. Torque control in robotics enable accurate joint and actuator movement. Similar to this, controlling torque in power systems guarantees the secure and effective operation of generators and turbines. Okay, how does torque work? Torque works by applying a force at a certain distance from a pivot or axis rotation, causing an object to rotate. The effectiveness of the force in generating rotation depends on three key factors. First, force magnitude. Assuming all other variables stay the same, the torque produced increases with the amount of force applied. Second is lever arm length. The lever arm is the distance measured perpendicularly between the force line of action and the axis of rotation. The torque generated for the same force is increased with a longer lever arm. Okay, lastly, angle of application. The angle between the force vector and the lever arm. Torque is maximized when the force is applied perpendicular to the lever arm. What is the function of torque? Inducing rotational motion. Torque is the driving force behind the object rotation. For example, when turn a doorknob or pedal a bicycle, torque causes the motion. Next is balancing system. In order to maintain stability, torque might sometimes work in opposition to someone. Equal and opposing torque on both sides and seesaw guarantee system balance. Transmitting power. Torque is necessary in mechanical systems like engines and gear trains, where rotational energy is moved to perform work. Controlling direction of rotation. The direction of an object turning around is determined by its torque. One direction of rotation is produced by favorable or clockwise torque, while the opposite is produced by not favorable or counterclockwise torque.
Purpose of torque. First, powering machine and vehicle. To move a car or turn a drill bit, for example, torque is employed in engine and motor to create and transfer rotational energy. Second is sensing efficiency. System can apply force more efficiency by modifying the torque mechanical advance, such as the use of gear or pulley. Third, stabilizing structure. Torque calculation ensure a bright tower and other structure can resisting twitching force, providing stability under various load. 4. Processing and control. Control torque application enable accurate force application and movement in automated system in robotics and manufacturing. Human interaction with tools. Torque enable tools like wrenches, screwdrivers and lever to function efficiently, allowing human to apply force and complete tasks with less effort. That's about a purpose of torque. Second, we talk about advantage and disadvantage about torque. First advantage, efficient power transmission. Torque enable the transfer of rotational energy in machine and vehicle, making it essential part of mechanical system such as gearbox, turbine and engine. Second is mechanical advance. Torque enable use to increase force with instruments like lever and wrenches, making things easier, such lifting heavy goods, lightning bolts. Third is versatility. Torque is applicable in a variety of industries, from manufacturing, robotics, automotive, and aerospace, displaying in adaptability in meeting of range mechanical requirement. Next, precision control. In robotic and automated system, torque control enable precise movement and action essential for task requiring accuracy. Next, structure stability. Torque analysis helps engineer design stable structure that can resist twisting and torsional force, ensuring safety and durability. Next advantage, optimize performance in vehicle. Torque is crucial for vehicle. Torque is crucial for vehicle performance. Find out driving dynamic, braking capacity and acceleration. Next, advantage is key to the gear ratio. Torque management in gear system allow for better control of speed and force, making vehicle and machine versatile in handling different operation conditions. Last advantage is improved motor efficiency. Torque optimization in electric and combustion engine ensure maximum output with minimal energy loss, improving overall system performance. Next, we talk about disadvantage about torque. First, torque disadvantage is complex calculation. Numerous elements such as force, direction, level arm length, and angle must be taken into account in order to calculate torque accurately. This can make analysis more difficult. Second, potential for overload. If applied incorrectly, expensive torque can result in mechanical failure, including stripped thread, bent shaft, or broken component. Third is energy losses. In mechanical system, torque transmission often involve friction leading to energy loss and reduced efficiency. Next is difficulty in measurement. To measure torque in dynamic systems such as spinning machinery of automobiles, specialized instruments like torque meter and required, and they can be expensive. Next is design challenge. In order to manage applied force, torque consideration in design required precise material selection and geometry modification, which can raise complexity and cost. Next is misapplication risk. The moment fasteners are over-tightened or under-tightened wrong, torque application can result in damage structure internally. Next is environment impact. Torque transmission in internal combustion engine contribute to fuel composition and emission, impacting the environment negatively. The last is depends on lubrication. Torque transmission system often rely on lubrication to minimize friction and wear, including additional environmental and maintenance issues. So that's about disadvantage and advantage about torque. And conclusion about torque is fundamental concept in physics and engineering that govern rotational motion and plays an indispensable role in mechanical system because it displays how successful a force, cause and project to rotate around and exist. It is important for learning and construct tools, machine, vehicle and structure. The ability of torque to exchange power transfer enable mechanical advantage to provide accurate control are some of the advantages. It is essential for application ranging from everyday tools to complex machinery machinery in industries like robotics, aerospace, and automotive. However, torque is disadvantaged as well, such as a potential for overloading, computational complexity, and energy losses. Energy and consumer may optimize torque's advantage and reduce its drawback. Having a solid understand of it. The creativity and functionality in modern engineering and technology depend on torque, whether it is in the development of efficient equipment, study structures, or engine performance enhancement. By balancing its advantage while solving weakness, torque keep advancement and effectiveness of a range of categories. That's all. And the next page you can see the reference for us. I will collect to do some reference.